Hello and welcome to Algebra 2, Chapter 8.3, and today we're discussing the new number, well, new to us anyway, e. Alright, so, recap of our numbers we've shared together. We've seen counting numbers, we've seen 0, we've seen negatives, we saw pi, we've seen I, and now what we have is the number e. Okay, and it is called the natural base, and it's a lowercase e, and Euler discovered it, and that's why we call it e, and he discovered it in 1736, so it's not a new number, but new to our discussion in math. And it is an irrational number, just like pi, and so how we get e is we use this expression, okay, the quantity 1 plus 1 over n to the nth power, and as n increases, so we could go through this, we could put in 1, we could put in 10, 100, 1,000, a million. As n increases, it will get closer and closer and closer to this decimal approximation, and that is what e is. So e is approximately that decimal, that's just part of it since it's irrational. Alright, so we're going to start out with some basic simplifying, and in this case you're going to treat it just like any other base, okay, when we're doing our exponents. And so if we look at 24e to the 8th over 8e to the 5th, remember you first look at your numbers, and so 24 divided by 8 is 3, and then we'll look at our e's, and if we're dividing, what do we do with our exponents? We subtract them, and so you just get 3e cubed. We are not evaluating these, we're just simplifying them. Okay. Looking at the next one, the quantity 2e to the negative 5x, all that to the negative second power. So we're going to start out by taking that negative 2 on the outside to everything, so it's going to be 2 to the negative 2, e to the 10x, because remember you multiply when you have an exponent to an exponent. Negative exponent drops to the bottom, so this is e to the 10x over 2 squared, and if we simplify that, it's e to the 10x over 4. Okay, so in this situation, it's just following our exponent rules. So looking at one more that it's following our exponent rules, on the top, I would probably go ahead and combine those first. And I believe we're going to get 12e to the 6th because we multiply the numbers and then we add our exponents. And then to simplify this, if we divide, 12 divided by 6 is 2. And we're going to subtract our exponents, which is going to give us an e to the negative second. So let's drop it down to the bottom as an e to the positive second. Alright, so that was simplifying. The next thing we're going to want to do, though, is evaluate. And so if you look at your calculator, if you have a graphing calculator, it should be about 3 above your on button. You're going to have to press second, and then you should have an e to the x, so it should look something like that. If you have a non-graphing calculator, you probably still have it someplace. It might be near an ln or a log. You might look by either of those. We'll talk about what those mean later. But look for some kind of e, and it could just be e like that. Okay? And so you're just going to type these directly into your calculator. So I'm going to do second e to the x, and I'm going to just type in a 3. And you might want to do these to make sure that you have found the correct place in your calculator. And it's 0.8553692, and it says round to the third decimal place, and so we would round that 5 to a 6. Okay, I'm going to do the same thing for e to the negative 0.12. Just type that into your calculator, and you get 0.887 when you round that to the third decimal place. Let's make sure we are rounding correctly. And e to the 0.85 gives you 2.340. Then there's a 9 in the third spot, but the 6 in the next spot tells you to round it up. And so you're going to round it up then to a 4. Okay, so the next thing we're going to do is we're going to graph. And this is going to be very similar to graphing either exponential growth or exponential decay. In fact, it really depends on this value right here, this R value, as whether it's going to be growth or decay. And I do want to say real quick, you know, typically a growth equation looks like this and a decay equation looks like that. And so those would both be if A is greater than 0. But keep in mind, if A is less than 0, then that's going to flip it just like it's flipped everything else, and so it actually would go down like this. And if A is less than 0 here, it's going to come up like that. Okay, so keep those in mind. So here's our first one we're going to graph. Y equals negative 3 e to the 0.5x. Okay, so just as we did before, we're going to start with a table, and let's go ahead and start with 0. And so if we put in 0 for x, that whole exponent's going to be 0, and you're going to get, you should get negative 3, right? Because anything to the 0 is 1. If you want to type it into your calculator, just to make sure, it does give us negative 3. Okay. And so what I was saying on the last slide, let's look here real quick. This being positive tells me this is going to be growth, which typically looks up like this. Okay, like if that was our axis in there. But because our leading coefficient's negative, that's going to flip it, and it's going to come down like that, which hence then our first point being below the x-axis. So we're just going to go over now to 1, and I would just type it in your calculator, negative 3e, and then it would be to just the 0.5. We get negative 4.946, so 1 and almost to negative 5. And then we'll come back and do negative 1. And I get negative 1.8196. Okay. And so this is going to still have an asymptote at 0, so this is going to come in here and come down, and there you go. Okay, domain is going to be all real numbers because it is going to go left and right forever. Range is going to be y less than or equal to, not equal to, less than 0. These can't be equal to, just less than 0. Alright, so we're going to graph another one, and this one has shifts, and so we're not going to graph the shifts yet. So we're going to start out by just graphing this part. And so start out with 0, which is just going to give you 1, because anything to the 0 power is 1. Okay, so 0, 1. Now, 0.4 there is positive, so this is going to be growth, and A is positive, so this is going to come up. If we go over to 1, you're going to get e to the 0.4, which is 1.492, so about 1.5. And if we do negative 1, we get 0.670. Okay, so there we go. And then we're going to shift our points. And so plus 1 shifts them left, and a minus 2 shifts them down. So we're going to go left 1, down 2. For each of those points. Okay, and so our asymptote, which was the x-axis, just shifted down 2, so we're going to come in along negative 2 here and come up. And there's our graph. We've got one more to look at. And it's actually not an example, but just another formula that you need to have written down. So beforehand, we have talked about compound interest formula, and so you should be aware of that now and have used that by now. And so if you notice, though, this right here is fairly similar to what the definition of E is. And so what we can do is we can replace that with E, and this is an equation for interest that's compounded continuously. So usually you have interest that's compounded monthly or quarterly, or you can have interest that's compounded daily. So this is interest that's compounded continuously, meaning you're continually getting interest and you're continually earning interest on that interest. And that is the formula, so make sure you have that written down. Alright, so that is our introduction to the letter E. Hope that answered your questions. And let me know if you have any more. We will see you later.